Hello. Today I'll be demonstrating cognitive data analysis using a Jupyter notebook and PixieDust. PixieDust is a library that lets you bring interactive charting to Jupyter notebooks. In this developer journey, we'll be using Facebook analytics data, and what we'll do to make it more cognitive is we're going to run the links and the articles and the images through tone analysis, natural language understanding, and visual recognition. And what we'll get is we'll get the ability to take the statistics from Facebook and not only look at the reach of individual posts and photos, but we'll be able to look at what the posts were about, what the language tone was, or what was in the picture, and now we can aggregate the data based on those things and use cognitive computing to do that all within one notebook. If you go to github.com/IBM/PixieDust Facebook Analysis, you'll find the README describes how to set this up and run it in IBM Data Science Experience. You'll also get the notebook is there that you can load right up. You can also use example data from the data/example directory if you don't have your own Facebook analytics data to use. If I go back out here, this is my Jupyter notebook. All the code is in a single notebook. Let me go up to the top. The Jupyter notebook, it has code, it has markdown, it has output, and now it has interactive graphs as well. So if I look at the top of this one, this Jupyter notebook happens to have a table of contents. You can click on the links and jump down below to different parts of it. But as a quick overview, what's included in this notebook is there is some setup to get your credentials and your services tied in so that we can run it. But then we load the data in from that CSV file. We prepare the data, and what we do is we're using pandas data frames to hold the data, and we use Beautiful Soup and also the requests library so that we can follow the links and pull things out of those links, and then we feed that into natural language understanding, tone analyzer, and visual recognition. Once we've done that preparation, now we have those Facebook metrics, but we also have tone and sentiment and keywords and entities and the objects in the pictures. Now we can use that information and explore and see what we learn from our metrics. To see what that looks like, I'll jump right down to the visualize data part of the notebook. I already ran the notebook, and what you get now is you'll see that there's a cell with a single line display tones. Tones is a pandas data frame that we already enriched with information from our tone analyzer API. We added a column that has the tone value in it, and the metrics are there from the Facebook analytics. Now we can chart them, and as you see what we get, here's an example of a pie chart that makes it look like the lifetime consumption numbers were very high for posts where the primary emotion was joy, as opposed to anger, sadness, fear, and disgust. But the interesting thing about this one, and I like to use it as an example for interactive charting, if I go into PixieDust options, you'll see I get to choose things like what key, emotion tone, or for tone analyzer we have a social tone and language style tone. We also have different metrics from Facebook that we can use. But in this case, I'm going to change the aggregation from sum to average. And it's interesting what happens. You'll see that the pie chart changed, and now instead of getting the idea that we're reaching most people with joyful articles, it turns out that if you look at on average which articles get the most reaction, we're really getting more reaction from articles that show disgust or fear. Now, I'm no marketing genius, so I'm not going to tell you how to take advantage of disgust and fear to improve your marketing presence, but it's good to know that the average response is skewed slightly differently than what you would get if you looked at the total response. So you get to click around so easily and see the different aspects of your marketing presence. The other things you get with PixieDust, for example, is I can easily change this to a bar chart. I can change it from, see the sort here is by the ascending keys. Now I can change it to be ascending by value. And you have some nice interactive charting available that way. I'm going to move forward to show you some of the other things we get out of this enriched data. The next chart Actually, it's very much like the one I just showed you. But the first time we did display tones, it brought up a pie chart. That's because the metadata here is what was stored and what told PixieDust how to initially show the data. But otherwise, the same one-liner is bringing up our tone in the posts again. This time we do a cluster by type, so we can see which of the metrics, how much of the number came from articles and how much came from the post text itself. And that's just done with this interactive cluster by setting. So that gives you an idea of what's in tone. If I move forward to see what else we're looking at, we've got some examples here using what we found using natural language understanding. Natural language understanding, we applied it to the post text, but we also followed the link and processed the article. So what we pulled out of there is it recognized in the text entities and keywords. This chart shows the entities by entity type, and the metrics we chose to chart this time show the Facebook likes and negative feedback from users. So we got that straight out of Facebook Analytics. But in order to read all the articles and identify what they were about, we had to go and use natural language understanding to process them to find out that some were about companies, people, organizations. And actually what we had when we did that with natural language understanding is it didn't only recognize that a company was mentioned, it does know what companies was mentioned. So if I pulled that information out, which I did not do, I could find out whether these comments were all about a specific company, which I'm assuming is IBM in this test data, but perhaps it was about companies we partner with. So really you'd want to look at the entity types and then maybe break it down further so you could cluster by entity type and find out which company, which person, which organization you were talking about. And that was all discovered by some very simple code in this notebook following those links. The next thing I have to demonstrate with natural language understanding is that we pulled keywords out of the articles. So reading those same articles, we pulled out keywords, and for example, a lot of the articles talked about robots. So we got a very high score for lifetime post consumption with robots. And you can chart the data here. You'll see that automated wine recommendations was fairly popular in both the posts and the articles. And again, we have the sorting options, the different renderers. This one's using Bokeh. The earlier one was using Matplotlib. And it gives you slightly different options in colors and choices, but we can do stacking and grouping and subplots, cluster by type, change the sorting. So it's nice interactive options. And as I mentioned before, if you wanted to pick different metrics, you can change the metrics, change the keywords, change the aggregation. Now moving right along, I wanted to see what we could get out of visual recognition. So out of these posts, we followed the image links. We got those using Beautiful Soup. We extracted the links, and image recognition processed each of them to see what it could find. So just like we charted based on tone and we charted based on keywords, now I'm charting based on things that Watson saw in these pictures. So here again, I can do charting that shows what kind of Facebook reaction we got from posts that had pictures of robots. So without having known tags or text or keywords of our own, we just pulled in all this data and went and processed it and identified that robots were influencing our marketing presence. So if you had a better sample of data and you wanted to find out whether you got more likes with robots or with kittens, this is how you could do it. It's as easy as running it through visual recognition and using a Jupyter notebook to chart it. The other thing visual recognition found is, in addition to things like robots and a reading desk, that's a good example for the next chart, I also pulled out the type hierarchy. Reading desk is the example I wanted to show you. The type hierarchy shows us it's furniture, it's a table, it's a reading desk. So it's very likely that as you're processing the data, you might not be interested in all the different types of furniture. You might be interested in just saying it's either furniture or it's a vehicle. So we have a hierarchy where we could have just charted furniture versus food. Or maybe you use furniture and food as your grouping in your cluster by, and you use the ultimate class as the individual bars or a stacked bar. So that information is all there with cognitive computing and Facebook Analytics. Now the other thing I pulled out from visual recognition was color. When we found all these classes, a lot of the classes gave me different colors. So I pulled those out specifically and added a separate column to our data frame just for color, because I figure you don't want to know it's either blue or it's a robot. You want to know it's a blue robot or a red robot. So in this case, it's a very simple example where I'm just charting the colors. Maybe you could find out if you get a more positive or negative reaction from your customers with blue versus red, or perhaps more likely these colors might be used in combination with some of the other metrics that we put in the other charts. So we kept it kind of simple for a developer to get in and play with, but once you have this information, you can tweak the data frames and then explore with PixieDust and then go back and iterate through that until you find the results you want. It's a great way to find hidden insights in your data from Facebook using cognitive computing.